Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will start on chapter 3 about the differentiation or derivative of the functions. On chapter 2, we learn about the function, the trigonometric function and hyperbolic function and their inverse. Trigonometric function and inverse trigonometric function, hyperbolic function and inverse hyperbolic function. So in this chapter, we need to know how to find the derivative of these functions. The derivative of hyperbolic function, the derivative of inverse trigonometric functions, the derivative of inverse hyperbolic functions, and we need to revise or to do review for some basic rule for derivative, how to find the derivative for the product of two functions, the division of two functions, the chain rule, and the implicit derivative. Okay, before start, we need to revise some basic rule in derivative. First, the derivative for any constant should be 0. The derivative for any constant is 0. The derivative for the function x is 1. The derivative for function x is 1. If x is multiplied by a constant like 2x, 3x, 5x, then the derivative is equal to this constant. For example, the derivative of a 3x is a 3. The derivative of 4x is 4. This is if I have x. Okay, if I have x squared, then I have a power here. So this power will become as a multiplication. So instead of x squared, I will have 2x. And the power here will be less by 1, will be decreased by 1. 2 minus 1 is 1. So the power of x here will become 1. So the power will become a constant. And 2 will be decreased by 1. So the derivative for x squared is 2x. Okay, the derivative for square root of x, this is similar to the power function because x squared here, or the square root of x is equal to x to the power 1 over 2. To the power 1 over 2. So as a power function, it will be 1 over 2. The power will become the constant. And 1 over 2 minus 1, which means minus 1 over 2 will be the new power. So the original power will be multiplied as a constant. The new power will decrease by 1. 1 over 2 minus 1, which means minus 1 over 2. The derivative for exponential x is equal to exponential x. This is e here is the natural logarithm e. But if we replace e here or the natural logarithm by a, any constant, a to the power x, now I have a constant is power to a variable. X here is the variable. So the derivative will be same ax, but will multiply by ln a. Here same ex, we multiplied by ln e, but ln e is equal to 1. This is why we didn't write it. Now for ln x, the derivative for ln x is 1 over x. The derivative for ln x is 1 over x. The derivative for logarithm x to the base a is equal to 1 over x divided by ln a. Here we divided by ln e, but because ln e is 1, we didn't write. So it's just 1 over x. So when we change e by another constant, a, so you need to divide by ln a. For a trigonometric function, the derivative for sine is cos. The derivative for cos is equal to minus sine. The derivative for tan x, sec square x. For this one, we will learn later, we will prove later. But for trigonometric function, we already know before that the derivative for sine is cos. The derivative for cos is minus sine. The derivative of tan x is sec square x. This is also the general rule. If you have multiplication by a constant multiplied by any function, Then the derivative is equal to the constant, same, multiplied by the derivative of the function. Multiplied by the derivative of the function. If you have power function x to the power n, and here is a constant, then the n will multiplied by x, and the new power will be decreased by 1, n minus 1. Just now we do x squared will become 2x, 2 minus 1 is 1, so x squared 2x. X cubed will be 3x squared. X cubed, if n equal to 3, then n here will be 3. Here 3 minus 1 is 2, so 3x squared. If I need to add or subtract two functions, and I need to find the derivative for addition or subtraction, then you need to find the derivative for f, add or plus the derivative for g. Same if you have subtraction of two functions, f minus g, then you need to find the derivative for f minus derivative for g. But this is not the case if you multiply two functions. If you multiply two functions, then I cannot say the derivative for f multiplied by g is equal to the derivative for f multiplied by the derivative for g. No, we have to apply what we call it the product rule. The product rule. So if you have a function f and a function g, you need to find f prime, the derivative for f, and g prime, the derivative for g. Then the derivative for multiplication, here will be equal to, I will multiply the derivative for f or the derivative for g, the derivative for f times g plus the derivative for g times f, the derivative for g times f. So you need to apply this product rule. If you have multiplication of two functions, f times g, then find the derivative for f first, find the derivative for g, but don't multiply the two derivatives directly by each other. No, you have to multiply the derivative for f by g plus the derivative for g multiplied by f. This is what we call the product rule. For the division rule or quotient rule, f over g. Here I have division for two functions. F over g. So I need to multiply this rule. I need to multiply the division rule. So again, if you have a function f and a function g, and you need to find the derivative for f over g, same like multiplication. First, find the derivative for f, then find the derivative for g, then apply this rule. The derivative for f times g minus the derivative for g times f over or divided by g squared. The one in the denominator here, g squared. G will be g squared. Then I will start from the derivative for f multiplied by g minus the derivative for g multiplied by f. This one is a special case from the division rule, 1 over f, when f equal to 1. So here I have in the denominator is f, so become f squared. Now the derivative for 1 is 0, so this term becomes 0, minus the derivative for f, so the derivative of 1 is 0, so this one becomes 0. Then I minus the derivative for f here times 1, so minus the derivative for f. So this is a special case when f equal to 1. Its derivative will be 0, so this term will be cancelled, minus g here is equal to f, so we have the derivative for f times f, which is 1. So this is a special case. For composite function, when we have function inside another function, like this one, sometimes we denote it f composite g or f of g of x, same. This is a composite function. I have function inside another function. Then you need to start from the first from the outer function, from the beginning one. You need to find its derivative first for g of x, then multiply by the derivative for inside function, for the inside function. Or sometimes if you need to write it as a chain rule, dy over dx, and y is a function of u, then you have to find. If y is a function of u and u is a function of x, then dy over dx will be dy over du times du over dx. If you have y, a function of u, and u is a function of x, then if you need to find dy over dx, then you need to find dy over du first, then multiply by du over dx. This is what we call a chain rule. So this is the basic rules that we will apply in this chapter. You need to be careful, know how to find the derivative for multiplication, for division, for addition and subtraction, and the chain rule. Okay, now we need to start how to find the derivative of hyperbolic functions. For cosh x, as we learned in chapter 2, it is defined by using the exponential function. We defined cosh x using exponential function. It is equal, by definition, ex plus e minus x over 2. Sine x, or sine hyperbolic x, defined by ex minus e minus x over 2. This is the main definition for cosh and sine. Cosh is ex plus e minus x over 2. Sine is ex minus e minus x over 2. So I will use this definition to find the derivative for cosh and sine. Now for tanh, we just defined sine over cosh. So we have this definition. For coth is 1 over tanh. So it will be ex plus e minus x over ex minus e minus x. Coshec is 1 over sine, shec is 1 over cosh. These are the definitions that we learned in chapter 2. So what we will do here to find the derivative for this function, I will use these definitions. First, I need to find the derivative for sine x. What is the derivative for sine x? To find the derivative for sine x, I will start from the definition here. ex minus e minus x over 2. So to find the derivative for sine x with respect to x, I have to find the derivative for this function. So for sine x, you need to find the derivative ex minus e minus x over 2. Now 1 over 2 is a constant. So constant will be outside of the derivative. Go outside of the derivative based on this rule here. Any constant multiplied by the function, just keep the constant and find the derivative for the function. So here the constant will not change. I still have 1 over 2. Now I just need to find the derivative for the function ex minus e minus x. The derivative for exponential function, same. Exponential function. Based on this rule. The definition, the derivative for exponential function, same. Equal to exponential function. Now I need to find the derivative for e minus x. The derivative for e minus x is equal to e minus x, same. E minus x, the derivative for exponential, same function, e minus x. But since I have minus x here, I have to multiply by the constant here. I have to find the derivative for minus x, because this is like a composite function. a composite between two functions, exponential u, where u is equal to minus x. Exponential u, where u is equal to minus x. So exponential u, same, exponential u, which is exponential minus x. I have to multiply by the derivative for minus x, by the derivative for minus x. Now the derivative for minus x is minus. The derivative for minus x is minus. So this means that minus e minus x, and I have another minus here. I have another minus here. So minus minus will become plus, minus minus plus exponential ex. If you look here for this definition, this is exactly cos x from the definition of cos hyperbolic, so it is equal to cos x. This is why the derivative for sine is cos. The derivative for sine is cos. Same for cos. The derivative for cos will be equal to sine. Will be equal to sine. Because here, the derivative for cos is ex. This is the definition of cos x. So 1 over 2 as a constant. We keep the constant. The derivative for ex plus e minus x. The derivative for ex same, ex. The derivative for e minus x, just now we calculate it equal to minus e minus x. So ex minus e minus x over 2, this is the definition of sine. This is the definition of sine x. Now how I can find the definition, the derivative for tan hyperbolic x or tan x. Same as I did for cos and sine. Same as I did for cos and sine. The definition, I will start from the definition of tan x. Tan is equal to sine over cos. So it is equal to exponential x minus exponential minus x over ex plus e minus x. Now I have a division between two functions, so I will apply the division rule. I will apply the division rule. So my first function here is f is ex minus e minus x. This is the first function. Now the second function, I have g. This is f and this is g. G is equal to ex plus e minus x. Plus e minus x. So now to apply quotient rule, I need to find the derivative for f first and then the derivative for g. The derivative for f now the derivative for f equal to the derivative for ex equal to ex minus the derivative of e minus x equal to what? The derivative for e minus x equal to what? This one.
Negative e, negative x.
Yes, negative e, negative x. Correct. Negative e, negative x. Same for the derivative for g will be ex minus e minus x. E minus x. Now I will apply the quotient rule after I found the derivative for f, the derivative for g. Now you can apply the quotient rule. The quotient rule, you need to divide. You go for this function g in the numerator, so you have to divide by g squared. You have to divide by g squared. Now here I need to multiply. You need to multiply the derivative for f times g the derivative for f times g minus the derivative of g f minus the derivative of g times f. So the derivative for f is ex minus minus become a plus e minus x multiplied by g, which is ex plus e minus x, minus the derivative for g times f. The derivative for g ex minus e minus x multiplied by ex minus e minus x divided by the square, divided by g squared. Now we just need to multiply. Ex multiplied by ex is e to x plus e minus x multiplied by e minus x is e minus 2x plus, now ex multiplied by e minus x equal to 1 because exponential 0 is 1. Ex multiplied by e minus x exponential 0 is 1. And again here e minus x times ex, again exponential 0, which is 1. So 1 plus 1 we have 2. We have 2. Minus, now here I have this part, minus exponential 2x minus minus plus exponential minus 2x minus. Now we have minus e minus x multiplied by ex minus exponential 0, which is minus 1, ex minus e minus x, again minus exponential 0, which again minus 1. So you have minus 2. You have minus 2. I did the multiplication here, but this is the result of multiplication. All this result multiplied by the negative here, or the negative sign here. So negative exponential e to x minus multiplied by positive become minus exponential minus 2x minus minus become plus, so plus 2. So plus 2. So now this is the result. Now what we have is exponential 2x here will be cancelled with minus exponential 2x. Exponential minus 2x will be cancelled with minus exponential minus 2x. 2 plus 2, we have 4. 2 plus 2, we have 4. So we have only 4 over ex plus e minus x squared. And this one, 4 is 2 squared. 4 is equal to 2 squared. So I can write it 2 over exponential x plus exponential minus x squared. Minus x. So this is the derivative for tangent x. This is equal to what? If you look here, this is equal to what? 2 over ex plus e minus x. This is the definition of which function? 2 over ex plus e minus x. This is 1 over cosh, because cosh is equal to ex plus e minus x over 2. Here I have 2 over this one. So this is equal 1 over cosh, not cosh. Which means sec square. It equal to sec square. So the derivative for tangent will be sec square. Actually, it is similar to trigonometric. If you remember trigonometric, we have the derivative for sine is cos, and here we have the derivative for sine is cosh. For trigonometric, we have the derivative for cos minus sine, but here the derivative for cosh is sine, not minus sine. For trigonometric, we have the derivative for tan is sec square. Here the derivative for tangent sec square. Sec square. So there is a similarity between trigonometric and hyperbolic function. So this is how we find the derivative for sine, cosh, and tangent. If you understand how we find this one, you can try at home doing the derivative for the other 3 functions. You can find the derivative for cos, cosec, and sec. You can find the derivative for these 3. similar as we did for cos, sine, and tan. Then you can, by same way, you can find the derivative. You will find like that. You can prove that the derivative for sec should be equal to minus sec tan x. For cosec is minus cosec x cos x. For cos is minus cosec square x. So you can try at home to prove this, to prove these derivatives. Now I need to go for examples. Now we need to go for examples. I need to find the derivative for this function. Y is equal to x cubed over sine x. X cubed over sine x. Here I have a derivative between two functions. A division. A division between two functions. So I need to apply the division rule. I have to apply the division rule. X cubed over sine x. So to solve this one, okay. For first one, x cubed over sine x. I need to find the derivative here. Thus, my first function is f equal to x cubed. My second function is g equal to sine x. Now I need to find the derivative for f and the derivative for g. This is the first step. The derivative for f is 3x squared. Here I have a power function. So since I have a power function, so the power will become as a constant, and I will decrease the power by 1. So 3 minus 1 is 2. So 3x squared. Now the derivative for g, just now we proved that the derivative for sine equal cos. The derivative for sine equal cos. Now, after I found the derivative for sine and the derivative for cos, I need to apply the quotient rule. I need to apply the division rule, which is dy over dx will be equal to over g squared. I will multiply f, derivative of f minus g, minus the derivative of g times f. Derivative for g times f. So this is the division rule or quotient rule. Now the derivative for f is equal to 3x squared multiplied by g, which is sine x, minus derivative for g, which is cos x, multiplied by f, which is x cubed, divided by g squared, which means sine squared. Sine square x. So this is the dy over dx. I have a division of two functions, so you need to apply division rule. But first step, specify your function f and g, find the derivative for f and g, then apply the rule. Then apply the division rule. Okay. Second example, I need to find tan cube 2x. Tan cube 2x. So for this one, tan cube y is equal tan cube 2x. Okay, for this one, we need to apply which rule? Is it multiplication rule, division rule, chain rule?
Chain rule.
Yes, chain rule. Because this one is function inside function. We have a function inside function. We have tan inside the power, and we have 2x inside the tan function. This is not a multiplication, because some students confuse between multiplication and chain rule. Chain rule, you have function inside function. Different from multiplication. So since I have functions inside function, I need to start from the outer one, from the first function, the outer function. Here the outer function is cube, the power. So I will start from the power. I will start from the power. So this is equal to 3 tanh. How I can find the derivative for the power function? The power will become as a constant. The power will become as a constant. So the 3 here become as a constant. Now the 3 should be decreased by 1. 3 minus 1 is equal to 3 minus 1 equal to. So instead of tanh cube, I will have tanh square, 2x. So this is the derivative for the power. Then this one will multiply by. Now I need to find the derivative for tanh. The derivative for tanh. After I found the derivative for the power, I will find the derivative for tanh. The derivative for tanh is sec square. So you have sec square 2x. Now I need to find the derivative for 2x, which is 2. So this is multiplied by 2. So you have 3 times 2 is 6. Tanh square 2x. Sec square 2x. Sec square 2x. Sec square. Some student, when they do the power function, they do like that, which is incorrect. This is some of student mistake usually. What they did is they do like that. Usually when they find dy over dx, they make it is equal to 3, and they didn't write tanh square. They start to find the derivative for tanh directly. So they said the derivative for tanh is sec square. Sec square 2x square times 2. Okay, so which is incorrect. Okay, when you find the derivative for power, keep the other function same. So tanh to x, I will keep tanh to x. I will only change the power. 3 tanh, instead of a 3, the new power will be square. You cannot find the derivative. I mean, you cannot find the power and inside the power find the derivative. No. This is incorrect. This one is incorrect. So you need to do function by function. You need to find the derivative and you keep the function here same. Because this is the rule. If you go back for the chain rule here, again, this one. If I have f g of x, you need to find the derivative for f, but you need to keep g of x. You need to keep g of x. Then the derivative for g will be multiplied outside. The derivative for g will be multiplied outside. So here when we need to find the derivative for the power, so you need the power function I have. The power will become the constant. 3 will become 2. That's all. Tanh to x will keep tanh to x. Okay, now I will go for tanh. The derivative for tanh is sec square. Keep 2x, not to change. The derivative for tanh, sec square. 2x I will keep. Now multiply by the derivative for 2x, which is 2. Which is 2. So you need to do step by step, function by function. Keep the other function for each step. Okay. Y equal to e cos for x squared. Y equal exponential see y equal exponential cos for x squared. Cos for x squared. X e cos for x squared. So here also I have a composite between functions, not a multiplied function. So I will start from which function we have to start? I have e cosh 4x squared, which is the first function that I have to find its derivative. Is it cosh or e or 4x squared? Because we have 4x squared inside cosh and cosh 4x squared inside the exponential. So I have to start from which one? What do you think?
We have to let u is equals to cosh 4x.
Yes, you need to start from exponential, not from cosh 4x. We need to start from exponential function here. This is so you have to start from the outer one, from the beginning one, because the power here for x only. Just to clarify this one, the power here only for x. Okay, maybe this is not clear or confused. The power here only for x, not for all the function. If it is for all the function, yes, you have to start from the power. But here we have to start from e. So what we will do is that exponential function derivative is same. So I will keep this one. The exponential function derivative is equal to exponential x. So not to change this one. Now multiply by the derivative for cosh 4x squared. Now I will start from cosh. So the derivative for cosh is sine. And inside sine keep 4x squared, not change. Then multiplied by 4x squared will be multiplied. Now I will multiply by the derivative for 4x squared. So the constant same for x squared as a power function. 2 times 4 will become 8. I have to multiply 4 by 2, which is 8. 2 minus 1 is 1. So we have x. So this is your derivative. This is your derivative. Start from the exponential one. So keep the other function because the derivative for exponential same, exponential x. So exponential x, exponential x, exponential cosh 4x squared same, exponential cosh 4x squared. Now multiply by the derivative for cosh 4x squared. The derivative for cosh, sine. Keep 4x squared. Now multiply by the derivative for 4x squared, which is 8x. So this is dy over dx. This is dy over dx. Okay, find the derivative for the following functions. Another example, y equal to cosh 3x. This one also composite function, not multiplication. This one still composite function. So I have to start from the outer one. I have to start from cosh. So dy over dx. The derivative for cos is sine 3x multiplied by 3. The derivative for 3x. The derivative for 3x. The derivative for cos sine. Keep 3x, don't change. Then outside you multiply by the derivative for 3x, which is 3. Which is 3. Same for b. Same for b. I have to start from to find dr over dt. I will start because this is also composite function. Function inside function. So the derivative for sine is cosh. 2 t squared minus 1. Not to change. Don't change the function inside. Now multiply by the function here. 2t squared minus 1. So 2t squared derivative is 40. Is 40. So this one will become 40. The derivative for constant is 0. So we just multiply by 40. So 40 multiplied by cosh 2t squared minus 1. Minus 1. If you have any question, you can ask. Either you open your mic or you can write on the chat also. For C. Okay, now we need to look for C here. C g of x, x minus 1 cube check square. This one a multiplication or a composite? x minus 1 cube check square x. Is it a multiplication between two functions or a composite between two functions?
Multiplication.
Yes, multiplication. This is a multiplication between two functions. So multiplications mean that I need to apply multiplication rule. So I have, because we have g here, we can make it u and v because we already have g. So the first function is x minus 1 cube. The second function we have is check square x. Check square x. Now we need to find the derivative for first function, the derivative for second function. Here I have x minus 1 cube. Now I have a composite between two functions. I have to start from the power first. So 3x minus 1. The new power 3 minus 1 is 2. 3 minus 1 is 2. Multiplied by the derivative of function inside. Multiplied by the derivative for x minus 1. The derivative for x is 1. The derivative for minus 1 is 0. So it should be multiplied by 1. Multiplied by 1. So we will not write the 1 here. Okay, check square x. First I have to start from the power. So 2 check x. The new power 2 minus 1 is 1. 2 minus 1 is 1. Keep check x. Now multiply by the derivative for check x. For check x. The derivative for check x is check tan x minus check x tan x. The derivative for check x is minus check x tan x. Minus check x. So I have to multiply by minus check x tan x. This one multiplied by minus check x tan x. Now I need to apply the multiplication rule to find the derivative for g. So you have to multiply the derivative for u times v plus the derivative for v times u. This is the multiplication rule to find dg over dx will be equal the derivative for u times v plus the derivative for v times u. The derivative for u is 3x minus 1 square multiplied by v, multiplied by check square, multiplied by check square, x, plus the derivative for v, 2, minus 2, because we have minus here, check square x tan x. Because if you look here, I have minus, so minus 2. Check x times check x is check square tan x. Check square tan x. This is the derivative for v. Multiplied by u multiplied by x minus 1 cube. X minus 1 cube. So this is dg over dx. So the first function, x minus 1 cube, its derivative, the power become 3x minus 1. 3 minus 1 is 2. This is the new power. It should be multiplied by the derivative for function inside. By the derivative here is equal to 1. So this is why we didn't write it. Now the second function is check square. Check square. So here I have check square. I have to start from the power first. So the power will become as a constant 2. The new power 2 minus 1 is 1. So 2 check x. Multiplied by the derivative for check x, which means minus check x tan x. don't make the power 2 multiplied by the derivative directly. The derivative is multiplied after you find the power and keep the function 2 sec x multiplied by minus sec x tanh x. Now apply the product rule. The derivative for u times v plus the derivative for v times u. So the derivative for v is the derivative for u 3x minus 1 square multiplied by sec square plus the derivative for v 2 sec x multiplied by minus sec x tanh x. Sec times sec square minus 2 tanh x multiplied by u, which is x minus 1 cube. X minus 1 cube. Okay. Y equal tan ln x. Y equal to tan ln x. Y equal to tan ln x. So here we have a composite, not a multiplication. We replace x by ln x. We replace x by ln x. The original function is tan x, but we remove x, we put it ln x. So we have tan ln x. So this is a composite function. I have to start from the outer one. I have to start from the outer function, which means from tan. The derivative for tan is sec square. Sec square ln x. The derivative for tan is sec square. Keep the function inside same. Keep the function inside same. Now multiply by the derivative for the function inside. So you have the derivative for ln x is 1 over x. The derivative for ln x is 1 over x. So you start from the derivative for tan, which is sec square, but keep the function inside. Don't change it. Now the derivative for the function inside, you need to multiply outside. So the derivative for ln x, 1 over x. So this is dy over dx. Dy over dx. If you have any question, you can write. If everything is clear, just write yes on the chat, so I can proceed for the implicit derivative. If everything is clear, just write yes on the chat. Okay, what about the others? Okay. Now, implicit derivative. Implicit derivative. For the implicit derivative, sometimes we couldn't. Actually, implicit derivative can be applied for any question, but we usually use it when we couldn't separate x from y. I need to find the derivative dy over dx by, for example, here x equal to y square sine for x plus cos y. I couldn't separate y from x. For all our previous example, I have y in one side and all the other side include x only. I have y, the other side include x only. I have y, the other side include x only. Here same, you have y, the other side include x only. So we can find the derivative directly. But like this example, both sides have x and y. Both sides cannot be, y and x cannot be separated. Cannot be separated. Here we have x, but in this side I also have x and y. I also have x. I cannot separate x from y. So in this case, how we can find dy over dx, we need to go for what we call implicit derivative. Implicit derivative. Same here, I couldn't separate y from x because we have x plus y inside the dash, so you cannot separate. So you have to go for what we call it the implicit derivative. Okay, if we start from the first one, a x is equal to y square sine 4x plus cos y, and I need to find dy over dx. The first step, you need to find the derivative for each term. You have to find the derivative for each term. Now I need to find dy over dx. I need to find dy over dx. If I find the derivative for x, then just find the derivative. If you find the derivative for y, you need to multiply by dy over dx. You need to multiply by dy over dx. So now here, the derivative for x is 1. The derivative for x is equal to 1. As a power function, 1 will become a constant. 1 minus 1 is 0, so x will be cancelled. The derivative for x is 1. So I found the derivative for the first term. x. The derivative for x is 1. No need to multiply by dy over dx because the variable that I found the derivative is x. And I already find the derivative for x, so no need to multiply by anything. Now go for the second term, y squared shine for x. This term is a multiplication between two functions. The first function is y squared, the second function shine for x. So here you need to apply the product rule. So the first function f you have is y squared. The second function is shine for x. Shine for x. So I need to find the derivative for this term. This is a multiplication between two functions. Now the derivative for y squared is 2y as a power function. But the variable here is y, not x. And I need to find the derivative with respect to x. So you have to multiply by dy over dx. If I have x squared, no need, because the variable is x. The variable that I need to find the derivative with respect to is also x. So no need. But here the variable is y, and the derivative with respect to x different. So you need to multiply by dy over dx. Okay. Now the derivative for g, the derivative for shine is cosh. So you have cosh for x multiplied by 4. Because the derivative for 4x is 4. No need to multiply by dy over dx because the variable here is x and we find the derivative with x. The variable is x and you find the derivative with respect to x. So if you have x, no need to multiply. If we find the derivative for y, you have to multiply by dy over dx. Now apply the product rule. The derivative for f times g plus the derivative for g times f. So the derivative for f, 2y dy dx. Here you have 2y. The derivative for f times g, 2y shine for x dy dx. 2y shine for x dy over dx plus the derivative for g times f, which means plus 4y squared cosh 4x. 4y squared cosh 4x. The derivative for f times g plus the derivative for g times f. This is the derivative for the second term. Now the derivative for the third term is cosh y. Cosh y, the derivative is equal to shine y. So you have to write here plus shine y. The derivative for cosh is shine. But the variable is y, so you have to multiply by dy over dx. So the first step, you need to find the derivative for each term in the equation. And if you have the variable y, you need to multiply by dy over dx. So the derivative for x is 1 equal to, here I have a multiplication between two functions. So the derivative for y squared is 2y dy over dx I have to multiply by dy over dx because the variable is y. Okay, sine for x derivative is cosh for x multiplied by 4. Since the variable is x, no need to multiply by dy over dx. So now the multiplication rule is the derivative for f, 2y sine for x multiplied by dy over dx. The derivative plus the derivative for g times f. The derivative for g is 4 cosh for x multiplied by y squared. So 4y squared cosh for x. Plus the derivative for cosh y, which is sine y dy over dx. Now, this is the first step. Now I need to find dy over dx. So the second step, I will separate the terms that include dy over dx in one side, the terms that not include dy over dx on the other side. So one side, I have two terms have dy over dx, this one and this one. These two terms have dy over dx. This one not have. So I will move this one to the left side, to the right side here. I will move this one to the left side here. So this one will become 1 minus sine 4y squared cosh 4x. This one not include dy over dx. So move to the other side. So minus 4y squared cosh 4x equal to the other terms, the other two terms. 2y sine 4x, 2y sine 4x, this term, and sine y plus sine y plus sine y. This one multiplied by dy over dx. Multiply dy over dx. So these two terms that include dy over dx, sine y dy dx, 2y sine 4x dy dx. I keep here on the right side, and the other side will include the terms that not have dy over dx. So 1 minus 4y squared cosh 4x. Now I can easily find dy over dx. Just divide both sides by this term. So dy over dx will be equal to 1 minus 4y squared cosh 4x divided by 2y sine 4x plus sine y. Just divide both terms by this one, both sides by this term, 2y sine 4x sine 4x. Okay. So y sine 4x over sine. So this is dy over. So again, what we did first, you find the derivative for each term. Then you need to separate the terms that include dy over dx with the term that not include dy over dx. Then divide by the term multiplied by dy over dx to have only the derivative, dy over dx. Okay, same for the second example, y tan x plus y. Y is equal tan x plus y. So here also I couldn't separate y from x, so I need to go for implicit derivative, Okay, what is the derivative for y? What is the derivative for y? What is the derivative? Sorry? What is the derivative for y? What is the derivative for y?
Y dx.
Yes, dy dx. It is 1, but I have to multiply it by dy dx because the variable here is y. You have to multiply, so don't write 1 only. Okay, the derivative for tan x plus y. The derivative for tan equal to what? Check square x plus y. Is it correct?
No.
Okay, what I have to do? This is not still not correct. I still have to complete. I have x plus y inside. I need to multiply by the derivative for x plus y. So the derivative for x is 1. The derivative for y is dy over dx. You need to multiply by the derivative for the function inside, x plus y. So the derivative for x is 1. The derivative for y is dy over dx. So you have here dy over dx equal to sec square x plus y plus sec square x plus y multiplied by dy over dx. I will distribute here. Sec square x plus y times 1, which means sec square x plus y. Sec square x plus y multiplied by dy over dx. I distribute here because I need to separate the terms that include dy over dx on one side and the term that not include dy over dx on the other side. You need to separate both. So here I have two terms with dy over dx, one term without dy over dx. So this will be equal to dy over dx minus sec square x plus y dy over dx equal to sec square x plus y x plus y. So I keep this one only here on the right side. So the other side including the term that have dy over dx. So dy over dx minus sec square x plus y dy over dx. Now I need to separate dy over dx alone. So dy over dx will be equal to sec square x plus y divided by 1 minus sec square x plus y. Sec square x plus y. So first step, you need to find each term and the derivative for each term. Then separate the term that include dy over dx in one side. The other side include the term without dy over dx. Take dy over dx as a common factor here. The remainder is 1 minus sec square x plus y. So divide by this term. So you have sec square x plus y over 1 minus sec square x plus y. This is the derivative for hyperbolic function. The same rules will be applied for inverse trigonometric function and inverse hyperbolic function. The same rule exactly. So we have 6 inverse trigonometric function first. Sine inverse, cos inverse, tan inverse, sec inverse, and cot inverse, cosec inverse. So to find the derivative for this function, the derivative for sine inverse x, 1 over square root 1 minus x squared. No need to memorize this derivative because it will provide it to you in the test. Just you need to know how to apply. I mean, we will give you what the derivative for sine inverse, cos inverse, tan inverse, and so on. Also for hyperbolic function, we give you the rule. But you need to know how to apply. So the derivative for sine inverse x is equal to 1 over square root 1 minus x squared. The derivative for cos inverse x is minus 1 over square root 1 minus x squared. The derivative for tan inverse 1 over 1 plus x squared. The derivative for cot inverse minus 1 over 1 plus x squared. Note for tan inverse, cot inverse, we don't have square root. We don't have square root. The square root only for sine inverse, cos inverse. For sec inverse, cosec inverse, you have the square root here, but multiplied by the modulus of x outside. Good. So how I can prove that the derivative for sine inverse x, how we know that the derivative for sine inverse x is equal to 1 over square root 1 minus x squared. So I need to prove this one, that the derivative for sine inverse x equal to 1 over square root 1 minus x squared. So the function is, my function is that I need to find its derivative is y equal to sine inverse x. I need to find dy over dx. So y equal to sine inverse x, this means that sine y equal to x. Take sine for both sides. So sine y, sine inverse x will be x. So sine y equal to x. And then use the implicit derivative. Use the implicit derivative. Implicit derivative, you need to find the derivative for each term. The derivative for sine is cos. And since the variable is y, you have to multiply by dy over dx. So cos y dy over dx equal to the derivative for x is 1. The derivative for x is 1. So now you can find dy over dx, which is 1 over cos y. 1 over cos y. Okay, now cos y, using this identity, cos square plus sine square always equal to 1. This is the identity that we have. So from this identity, you can easily prove that cos y from here will be equal to 1 minus sine square under the square root. Just move sine square here. So 1 minus sine square. This is equal to cos square. To find cos, just take the square root. So cos y will be equal to the square root 1 minus sine square y from this identity. And sine square y is x squared. Sine square y is x squared. So this is how we prove that the derivative for sine inverse x equal to 1 over square root 1 minus x squared. 1 over square root 1 minus x squared. By the same way, you can prove cos inverse. By the same way, you can prove cos inverse and tan inverse, cot inverse, all the others. If you understand sine inverse, you can prove all. Because it just, you need to take y equal, for example, to cos inverse x. This means that cos y equal to x. Just use the implicit derivative to find dy over dx. Exactly same steps. Okay, now we need to find the derivative for these functions. You will apply the same rule for product, for composite, for division, and for power function. First one, f of x equal to tan inverse square root of x. Tan inverse square root of x. Note that the derivative for tan inverse x is 1 over 1 plus x squared. This is the general rule for the derivative for tan inverse x. So I will use this rule. I have tan inverse square root of x. Tan inverse square root of x. Note that this is not a multiplication. This is a composite function. instead of tan inverse x, I have tan inverse square root of x. Tan inverse square root of x. So how I can find the derivative? I will start from tan inverse x. From tan inverse x. So the derivative for tan inverse x is 1 over 1 plus x squared. So 1 over 1 plus. Here I don't have x, I have square root of x. So square root of x squared. Square root of x squared. Tan inverse x, you have x squared. Tan inverse square root of x, you need to replace x by square root of x squared. Now you need to multiply by the derivative for the square root. And again, the derivative for square root of x as a power function. Because the square root of x is equal to the x to the power 1 over 2. So as a power function, 1 over 2 will become a constant. 1 over 2 to find its derivative. 1 over 2 is a constant. X, 1 over 2 minus 1, which is minus 1 over 2. Or you can make it square root of x below here. This one is equal to each other. So 1, or you can keep it like this one is okay. 1 over 1 plus square root of x squared, applying the rule here. Now you need to multiply by the derivative for square root of x, which is 1 over 2 square root of x. Now we need to find dg over dt. I have sine inverse 1 minus t. Again, I have a composite function. Instead of sine inverse t, I have sine inverse 1 minus t. So I will apply the rule of sine inverse. The rule of sine inverse is 1 over square root 1 minus x squared, this one. So we'll apply here. dg over dt is 1 over square root 1 minus. Here I have x squared, but I will replace x by this function, 1 minus t. 1 minus t squared. 1 minus, because I apply this rule. This is the rule that we apply. The derivative for sine inverse x, 1 over square root 1 minus x squared. So just replace x by the function 1 minus t. So 1 minus t squared. Multiplied by the derivative for 1 minus t. The derivative for 1 is 0. The derivative for minus t is minus 1. So you have minus 1 over 1 minus 1 minus t squared. 1 minus. Okay, now h of x, sec inverse e2x. Sec inverse e2x. Sec inverse e2x. I will start from the derivative for sec inverse. What is the derivative for sec inverse? 1 over the modulus of x multiplied by the square root x squared minus 1. So you need to take this one and apply it. And apply it. So this is the rule, and I will apply this rule. I will apply this rule. So we have sec inverse e2x. So the derivative for this for sec inverse is this one, but each x will be replaced by exponential 2x. Each x will be replaced by exponential 2x. So instead of x, I will write e2x. Instead of x squared, we write e2x squared minus 1. So this is the derivative for sec inverse e2x. Now I need to multiply by the derivative for e2x. Exponential function derivative, same function, e2x. The derivative for e2x is e2x. Then multiply by the derivative for 2x, which is 2. Now you can cancel, because this one can be cancelled here, this one, because exponential 2x is always positive. So the modulus here is not significant. e2x is always positive. So you have 2 over exponential 2x squared, which is exponential 4x minus 1. So this is the derivative. So you need to start from sec inverse, applying the rule of derivative for sec inverse. Usually these rules given to you in the test. Now x will be replaced by e to x because we don't have sec inverse x, we have sec inverse e to x. So in the rule, replace x by e to x. Replace x by e to x squared. And then multiply by the derivative for e to x, which is the exponential function itself, multiplied by the derivative for 2x, which is 2. Again, here, if I need to find the derivative for tan inverse x squared to the power 4. Again, a composite between three functions here. I have x squared inside tan inverse, and tan inverse x squared is inside the power function. So the power function is the first function. You have to start from the power. So 4, the power will become a constant. The new power will become 3. 4 minus 1, which is 3. Inside, we didn't change. Keep the function inside. Just find the power function. The power function, 4 will become a constant. Reduce the power by 1. 4 minus 1 is 3. Now go for the inside. Multiply by the derivative for tan inverse is x squared. The derivative for tan inverse, this one. This is the rule. So here 1 over 1 plus, I don't have x, I have x squared. So x squared here will become x squared squared. Replace x by x squared. And you have a square from the formula itself. Multiplied by the derivative for x squared, which is 2x. So again, I start from the power. Then I go for the derivative for tan inverse, but keep this is not tan inverse x. This is tan inverse x squared. So you have to replace x by x squared. Then multiply by 2x. Then multiply by 2x, which is the derivative for x squared. Another example, f of x is ln sine inverse for x. This one is a composite, right? Is it a composite function? If this one is a multiplication, it should be written like that. This one is a composite, not multiplication. In case to be multiplication, it can be written like that. Ln x sine inverse for x. If it is written like that, this is a multiplication between two functions. The first function is ln x. The second function sine for x. So these are multiplication two functions. But here I don't have ln x. I have ln for sine inverse for x, which means that I didn't multiply ln x by sine inverse for x. What I did, I remove x, and then I take the ln, and I said I need to find ln sine inverse for x. So now become a composite, not a multiplication. So we have, instead of ln x, we just replace x by sine inverse for x. So this is a composite function. This is a composite function, not a multiplication. So the question is, what is the derivative for ln? What is the derivative for ln? The derivative for ln x is 1 over x. The derivative for ln x is 1 over x. Here I have ln sine inverse for x. So the derivative is 1 over sine inverse for x. Sine inverse for x. Now I need to find the derivative for sine inverse for x. Sine inverse for x. So I need to find the derivative for sine inverse. The derivative for sine inverse, this is the formula. 1 over square root 1 minus x squared. So you need to multiply by 1 over square root 1 minus. It should be x squared, but here I have sine inverse for 4x, not for x. So it will become 4x squared, not x squared. Now multiplied by the derivative for 4x, which is 4. which is 4. So we need to start for the composite, start from the outer function, which is ln. The derivative for ln 1 over x. But here we have sine inverse for x, so 1 over sine inverse for x. Multiplied by the derivative for sine inverse for x, another composite functions. So sine inverse for x, the derivative for sine inverse is 1 over square root 1 minus, should be x squared if you have sine inverse x. But you have sine inverse for x, so x squared will be 4x squared. Multiplied by the derivative for 4x, which is 4. Oh, here, check. How can I find, this is the solution here. Maybe I write it for. Okay, what about this question? Tan inverse tan 3t squared minus 1. How we can find the derivative here? Is it a composite function, multiplication function, or what? We need to start from tan inverse. Okay, the derivative for tan inverse, we need to follow this rule. 1 over 1 plus x squared. This is the derivative for tan inverse. So here I have tan inverse. Here I have tan inverse. Inside the inverse, I have tan 3t squared minus 1. So tan inverse derivative 1 over 1 plus x squared. So x squared will be tan 3t squared minus 1 all 4 squared. Tan squared 3t squared minus 1. Okay, then I need to go for the derivative for tan. The derivative for tan is 6 squared. 6 squared 3t squared minus 1. And the derivative for 3t squared is 60. Because a power function, 2 times 3 is 60. Is 60. So you have this one. 60 multiplied by 6 squared, 3t squared minus 1 over 1 plus tan squared 3t squared minus 1. So this is dy over dt. We start from tan inverse 1 over 1 plus x squared, which was 1 over 1 plus, instead of x squared, tan squared 3t squared minus 1. Then multiply by the derivative for tan, which is 6 squared, 3t squared minus 1. Then multiply by the derivative inside, which is 60, So this is dy over dt. So what about if I cancel tan inverse with tan? Did you agree or not? Can you agree with me if I cancel tan inverse with tan? Just make it y equal to 3t squared minus 1. Actually, after we find the derivative here, 6 squared is equal to 1 plus tan squared. I mean, here, also this one will be equal to 6t, because if you go for the identity, 1 plus tan squared is 6 squared. So this will be cancelled with this one. So the final answer is 6t. So this is why I told you from the beginning, you can cancel tan inverse with tan. So the derivative is 6t. The derivative on both solution will be equal to 6t. Any function which its inverse give you the original value. For example, exponential and ln function. When we say ln ex equal to x, e ln x is equal to x, because both functions are inverse to each other. So tan inverse tan, they can cancel each other. So remember 3t squared minus 1. And for tan, you have no condition like sine and cos. Sine and cos is between minus 1 and 1. For tan, it's okay. It's correct for all x. So you can cancel from the beginning to make the derivative 6t. Or if you go like this one, also can. But not that from the identity. 1 plus tan squared is 6 squared. If you go back for the identity we give to you on chapter 2, you will find that 1 plus tan squared is 6 squared. So 6 squared will be cancelled with 1 plus tan squared. So they only have 6t. So still can. Find the derivative dy over dx for this one. This one is implicit one. We cannot separate x from y, so we will go for finding dy over dx. Okay, for the implicit, we will agree about the steps. First step, you need to find the derivative for each term. Second step, then you need to separate dy over dx. Okay, x tan inverse y equal to x squared plus y. The first term, x tan inverse y, is a multiplication between two functions. A multiplication between two functions. Your function x, the second function tan inverse y. Now the derivative for f is 1. The derivative for g is tan inverse y. 1 plus 1 y squared. Okay? Then I need to apply the multiplication rule. Okay, so this one, the first term will be equal to the derivative for g times f, which is x, which is equal to x over 1 plus y squared. The derivative for g times f plus the derivative for f times g plus tan inverse y equal to. So this is the derivative for the first term. Okay, what about the derivative for the second term? The derivative for x squared is equal to x. Plus the derivative for y should be 1, but because the variable is y, you have to multiply by dy over dx. Okay? Is it okay or not? First, I need to find the derivative for the first term. So I have a multiplication between two functions. So I apply the multiplication rule. The derivative for x is 1. The derivative for tan inverse y is 1 over 1 plus y squared. So apply the multiplication rule. The derivative for g times f plus the derivative for f times g equal to, the second term is x squared is 2x plus the first term is y, the 1, but because the variable y is equal to dy over dx. Yes, sure. You have to multiply g by dy over dx. So I make this mistake. Okay, so this one have to multiply by dy over dx. Actually here, I couldn't, this is incorrect to only 1 over 1 plus y squared. It should be multiplied by dy over dx because the variable is y. So just now I keep it here. I didn't write dy over dx. So what I did is wrong. I have, since the variable is y and the derivative with respect to another variable x, so you need to multiply by dy over dx. Here the variable is x, the derivative for x as well, so no need. But for y you have to. So tan inverse y will be multiplied, its derivative will be multiplied by dy over dx. So when I multiply the derivative for g times x, then x over 1 plus y squared dy over dx plus tan inverse y equal to x squared, no need, just find the derivative, 2x. Y here, the derivative is 1, but have to multiply by dy over dx. Now the second step, separate the terms, including dy over dx on one side, the term that not include dy over dx on another side. So you have So you have x 1 plus y squared. This is the first term, minus, okay, dy dx minus dy dx equal to 2x minus tan inverse y. 2x minus tan inverse y. Separate the terms that include dy dx on one side, either the left or the side or the right side, and the other terms on the other side. 2x minus tan inverse y. Now take dy over dx as a common factor, so you have x 1 plus y squared minus 1 dy over dx equal to 2x minus tan inverse 1. And then you need to multiply by or to divide by this term, so dy over dx equal to 2x minus tan inverse y multiplied by 1 over x plus over 1 plus y squared minus 1, or divided by this term. So this is dy over dx. You need to divide both sides by this term. So this is dy over dx. So first step, find the derivative for each term. Second step, separate the term that include dy over dx on one side, the other term on the other side. Then divide, take dy over dx as a common factor and divide by this term both sides. Okay, sine inverse, this is also implicit. Sine inverse xy plus pi over 2 equal to cos inverse y. Now I need to use the derivative for sine inverse and the derivative for cos inverse. Okay, the derivative for sine inverse, to find the derivative for the first term, is 1 over 1 minus xy squared. But here I have to multiply by the derivative for xy. So I have a multiplication between two functions. The first function is x, the second function is y. So the derivative for x is 1, the derivative for y is 1, but multiplied by dy over dx. So by using multiplication rule, it is equal to x multiplied by dy over dx. So this one, x dy over dx plus 1 times y. First, x dy over dx plus y. Now this is the derivative for sine inverse xy. I start from the derivative for sine inverse, which is 1 over square root 1 minus x squared, but x squared will be written xy squared, multiplied by the derivative for xy. This is a multiplication of two functions. The first function is x, the second function is y. The derivative for x is 1, the derivative for y dy over dx. So just apply the multiplication rule. Now the derivative for pi over 2, this is a constant equal to 0. So this one cancel. This derivative is equal to 0. Equal to cos inverse y is minus 1 over 1 minus y squared. This is the derivative for cos inverse. X minus 1 over square root 1 minus x squared. So x squared will become y squared multiplied by dy over dx. multiplied by dy over dx. Now I found the derivative for each term. This term derivative is 0, so cancel. So you have sine inverse xy cos inverse 1. The derivative for cos inverse is minus 1 square root 1 minus y squared. You have to multiply by dy over dx. Sine inverse xy is sine inverse 1 over square root 1 minus xy squared multiplied by the functions inside xy. So x dy over dx plus y, if you apply the multiplication rule. Now the second step, separate dy over dx. Separate the terms, including dy over dx. So you have x over square root 1 minus x square y square plus 1 over 1 minus y square. This one dy over dy dx equal to minus y. Equal to minus y. So here minus y, I bring it to the right side, so become minus y. And this term is moved to the left side, so you have plus 1 over square root 1 minus y squared. And this term x 1 over square root 1 minus x squared y squared dy dx. So just now you need to find dy over dx. Is equal to minus y multiplied by 1 over x 1 minus x squared y squared plus 1 over 1 minus y squared. No need to simplify. No need, just find dy over dx. No need to simplify the term. Just find what dy dx equal to. So if everything is clear, sorry, yes, I have this mistake just now. 1 over square root 1 minus xy squared is multiplied by this term and also by y. And also by y. So this one is equal to minus y over 1 minus x squared y squared. So here the term, minus, good, thank you so much, Tim. Thank you so much, Nim. Good. Yes, I did a mistake here. So here, because this one is multiplied by x dy over dx and also multiplied by plus y. So when I move the term to the left, to the right side, I just move minus y, which is wrong. I have to move minus y multiplied by 1 over square root 1 minus xy square. Yes, correct. Okay, now for sine inverse u. Okay, this is the combi. Now for inverse hyperbolic function, the same rules again. The same rules for derivative, for multiplication, whatever the functions are, the same rule for product, the same rule for division, the same rule for chain rule. Okay, now for sine inverse x. For sine inverse x, the derivative is equal to 1 over square root 1 plus x squared. 1 plus x squared. Okay, so this formula again, it will be given to you in the test. No need to memorize what is the derivative for each function. We give you the derivative for all function. What you need to know how to prove and how to apply. So prove that the derivative for sine inverse x is equal to 1 over square root 1 plus x squared. 1 over square root 1 plus x squared. So by the same method that I did for inverse trigonometric function. Y is equal to sine inverse x, so you need to find dy over dx. So just take sine for both sides. So sine x, or sine y will be equal to x. Sine y will be equal to x. So sine y will be equal to x, then do the implicit derivative. The derivative for x is 1. The derivative for sine y is cos y dy over dx. Cos y dy over dx, which means that dy over dx 1 over cos y. Now for the identity that cos y, we have this identity that cos square minus sine square is equal to 1. This is the identity for hyperbolic function. From this identity, cos square y is 1 plus sine square. So cos y will be the square root 1 plus sine square y, and sine square y is x. Sine square y is x square. So exactly same as we did for sine inverse and cos inverse. Similar for sine inverse, cos inverse. Take y sine inverse, then x sine y. Then x sine y. Do the implicit derivative. You will have 1 over cos y. Now apply the identities. From the identity, because I have sine y, so you need to relate cos by sine. So the relation comes from this identity. Cos square minus sine square is 1, which means that cos y square root 1 plus sine square. And sine y is x. So sine square y is x square. So the derivative dy over dx, or the derivative for sine inverse x dx, is equal to 1 over square root 1 plus x square. 1 plus x square. Actually, this one you can prove it by another way. Here we just prove it by using implicit derivative, but you can do by using the definition. From this step, when you take x equal to sine y, no need to find the implicit derivative. Just make it sine y is equal to ey minus e minus y over 2. ey minus e minus y over 2. And then you can apply the implicit derivative to find dy over dx. Now you can apply implicit. This is another way to prove. I mean, here you can find it x, okay, 1 is equal to 1 over 2, okay, exponential y minus exponential y minus exponential minus y here as exponential minus y multiplied by minus become plus. Multiply dy, because both terms have y, so you have to multiply both terms by dy over dx, and then you need to find dy over dx from here. Dy over dx from here. Or another way, you can find the definition directly, because sine inverse x, from the definition of sine inverse, it is equal to ln x plus x squared plus 1. X plus square root x squared plus 1. You can use definition for sine inverse x. You can find the derivative for ln. Also can. So you have 3 ways to prove. Either you go for implicit derivative here, or you go for the definition of sine, or you go for definition of sine inverse. All can. You can try this one too. If you couldn't, I can give you later the solution how to find dy. Here just make direct derivative, you will get dy over dx. Okay, same way you can prove cos inverse, tan inverse, cos inverse. In the test, when we ask you to prove, only one proof you can use. No need to, we didn't force you to use anyone. Just if you understand one of the proof, you can follow. Okay. So by same way, you can find the derivative, you can prove that the derivative for cos inverse is equal to 1 over square root x square minus 1. The derivative for tan inverse 1 over 1 minus x square. Note here that tan and cos don't have square root. Similar for tan inverse and cot inverse. But tan inverse, cot inverse 1 plus x square. but tan inverse cos inverse 1 minus x squared. But in both cases, tan or tan inverse cos or cot inverse don't have square root. Sine and cos both have square root. Both have square roots. Sec and cosec, usually we multiply by x or by the modulus. It depends on the value of x. So these are, you can prove that the derivative for tan inverse of this one, the derivative for cos inverse is this one, by using same method that we used to prove for sine 1. For sine 1. Okay. Now find the derivative. We need to apply the rule. Okay, we need to apply the rule to find the derivative. Sine inverse, find the derivative for sine inverse 1 minus 3x. We need to find the derivative. So here this is a direct one, dy over dx equal to the derivative for sine inverse is 1 over square root x square plus 1. This is the rule. So you need to apply this one. 1 over square root x square plus 1. I don't have x square. I have 1 minus 3x. So 1 minus 3x square plus 1. Because this is a composite between two functions. So you need to keep the function inside. So instead x, 1 minus 3x. 1 minus 3x square plus 1 from the formula. Now you need to multiply by the derivative for the function inside. 1 minus 3x. The derivative for 1 is 0. So the derivative for minus 3x is minus 3. The derivative of minus 3x is minus 3. So minus 3 multiplied by 1 over square root 1 minus 3x squared plus 1. This formula from the derivative for sine inverse x. 1 over x squared plus 1. Now cos inverse 1 over x. Here also I have a composite between functions. I have a composite between function. Instead of cos inverse x, you have cos inverse 1 over x. 1 over x. So I will start from the beginning function or from the outer function, cos inverse x. The derivative for cos inverse x, apply this rule. 1 over square root x square minus 1. 1 over square root x square minus 1. So here we have dy over dx 1 over square root x square minus 1. So x square, I have 1 over x. So 1 over x square minus 1. I don't have x, I have 1 over x. So x here will be replaced by 1 over x. Will be replaced by 1 over x. Because we have 1 over x here. Now multiply by the derivative for 1 over x. What is the derivative for 1 over x? 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 Do you know how to find the derivative for 1 over x? 1 over x. How can we find the derivative for 1 over x? One over x. Is it ln x? Is the derivative for 1 over x equal to ln x? Ln x. X minus 1 over x squared. Okay, 1 over x not equal to ln x. The derivative for ln x equal to 1 over x. The derivative for ln x equal to 1 over x. But the derivative for 1 over x not ln x. This can be done as a power function. X minus 1. This is your function. So as a power function, it will be minus x minus 1. Minus 1 is minus 2. Okay, so we didn't write it like that. We write it 1 over, because x minus 2 will become 1 over x squared. So Wong and Lem are correct. Mirza, you write the function, but you need to find its derivative. As a power function, x to the power minus 1. So we need to find its derivative as a power function. So minus 1 over x squared. But don't confuse and write it ln x, because ln x, the derivative for ln x is 1 over x. But 1 over x as a function, its derivative not equal to ln x. It is equal to minus 1 over x squared. Minus 1 over x squared. Good. Okay, sine inverse tan 3x, also a composite between two functions. The first function is sine inverse x. So I have to go for the derivative for sine inverse. Sine inverse 1 over square root x squared plus 1. 1 over square root x squared plus 1. So dy over dx equal to 1 over square root x squared. Here will be tan 3x squared, or tan squared 3x plus 1. Multiplied by the tan 3x, the derivative for tan is sec squared 3x multiplied by 3. Multiplied by 3. So I found the derivative for sine inverse first, then the derivative for tan sec squared. The derivative for 3x is 3. Okay, what about f of t tan inverse t squared over 1 minus sec t? Here we have division of two functions, so you have to apply division rule. First function is tan inverse t squared. The second function is 1 minus sec t. So the derivative for f, okay, the derivative for tan inverse is, you need to apply the formula for tan hyperbolic inverse. The derivative for tan hyperbolic inverse x is 1 over 1 minus x squared. 1 over 1 minus x squared. So here 1 over 1 minus x squared, which means t squared squared. T squared squared. Okay, the derivative for g, the derivative for 1 is 0. The derivative is constant is 0. The derivative for sec is sec tan. So minus sec t tan t. Minus sec tan. Minus 6. Now then apply the division rule. Apply the division rule. The division rule, you have to multiply the derivative for f times v minus the derivative for g times f. So df dt equal to the derivative for f, 1 over 1 minus t to the power 4 multiplied by 1 minus sec t minus the derivative for g times f. So minus minus become plus sec t tan t tan inverse t square all over g square, which is 1 minus sec t square. 1 minus sec t square. So will be all divided by g square. Okay. Same for y square root cos inverse u. So you need to define, this one is equal to cos inverse u to the power 1 over 2. To the power 1 over 2. So you have to start from the power. So dy over du will be 1 over 2 cos inverse u. 1 over 2 minus 1 is minus 1 over 2. Now multiplied by the derivative for cos inverse u. So cos inverse u will be equal to 1 over 1 minus u squared. 1 over 1 minus u squared. So 1 over 1 minus u squared. 1 u squared. So start from the power function first. Keep the function inside without change. Then multiply by its derivative outside. This is the last two examples. Now y is cos for x, cos inverse for x. Here is a multiplication between two functions. Here is a multiplication between two functions. First function is cos for x. Second function is 4x cos inverse for x. Cos inverse for x. Second function is cos inverse. First function is cos for x. The second function cos inverse for x. Now the derivative for f, the derivative for cos is minus sine. So minus sine for x multiplied by 4. So minus 4 sine for x. The derivative for g, 1 over the derivative for cos inverse is 1 over square root x square minus 1. So you have square root 4x square minus 1. Minus 1 multiplied by 4. Multiplied by 4. Then apply the multiplication rule. Apply the multiplication rule. So dy over dx equal to 4 over 16x square minus 1 cos for x. This is the derivative for g times f. 4 cos for x over 16x square minus 1 plus cos inverse for x minus 4 sine for x. Minus 4 sine for x. So just apply the product rule. And the last example is the implicit example. It's the implicit one. Y cube minus sine inverse xy equal to 0. So I need to find the derivative for each term. So you have 3 y squared because the variable is y, so dy dx minus sine inverse xy. The derivative for sine inverse is 1 over square root 1 plus x squared or x squared plus 1. Apply the rule for sine inverse is x squared plus 1. So we have here we have xy, so x squared y squared plus 1. Now xy are a product of two functions. The first function is x, the second function is y. So the derivative here is 1, the derivative here is dy dx. So x dy dx plus y plus 1. X dy dx plus y. Now we need second step equal to 0. The derivative for 0 is 0. So I just need to separate the terms that have dy dx. So 3y squared minus x over square root x squared y squared plus 1 dy dx will be equal to, move this term to another one. This term is minus y over square root x square y square plus 1. So the minus become positive. So you have y over x square y square plus 1. X square y. Now you can find dy over dx, which is equal to y over x square y square plus 1 over this term, which is 3y minus x over square root x square y square plus 1. X square plus 1. So this is dy dx. So the implicit function. So by this example, we end this chapter.